The closest star beyond our Sun, Proxima Centauri, is about 4.24 light-years away. That means the light you see tonight left that star over 4 years ago. Many of the stars visible to the naked eye are hundreds or even thousands of light-years away. You are not seeing them as they are. You are seeing history. People often imagine space as a three-dimensional room with bright dots sprinkled inside. But the sky is more like a time machine. Every glance upward is a glance backward. And that changes everything. Now here's where imagination really takes off. You look at the night sky, see thousands of stars, and think, with so many of them, there must be life out there, intelligent life. It feels almost mathematically unavoidable. Our galaxy alone contains somewhere between 100 and 400 billion stars. And we now know that planets are common. Many stars have planetary systems. Some planets sit in the so-called habitable zone, where liquid water could exist. So the logic goes, lots of stars plus lots of planets equals lots of civilizations. But let's slow down. Large numbers don't automatically guarantee outcomes. They depend on probabilities. And here's the uncomfortable fact. We don't actually know the probability that life arises, or that it evolves intelligence, or that intelligence builds radio transmitters. We have exactly one confirmed case, Earth. Imagine trying to estimate how often a rare plant grows in a forest, but you've only ever found one example. You can't confidently say it's common just because the forest is big. The misconception is that possibility equals inevitability. It doesn't. Yes, there may be life around distant stars. It's entirely plausible, but plausible is not proven. When we look at those distant suns and picture alien cities orbiting them, we may be projecting our own story outward. Curiosity is wonderful, but until we have data, the honest position is this: the stars are full of potential. Whether they are full of intelligence, that remains an open question. Now suppose for a moment that there are intelligent civilizations orbiting some of those distant stars. Here comes the next illusion, that meeting them is simply a matter of time. We imagine starships gliding between systems, conversations across the galaxy, maybe even visitors dropping by. But let's look at the numbers calmly. The nearest star system, Alpha Centauri, is about 4.24 light-years away. Light, the fastest thing in the universe, takes over 4 years to get there. Our fastest spacecraft would take tens of thousands of years. Tens of thousands. And that's just the nearest star. The Milky Way is about 100,000 light-years across. Crossing it at light speed would take 100,000 years. At our current speeds, far longer than human civilization has existed. Now here's the subtle trap. We're used to earthly distances. A flight across the ocean takes hours. A signal across the planet takes milliseconds. Our intuition is shaped by a small world. But the universe is not small. Even radio communication is slow on cosmic scales. Send a message to a star 100 light-years away, and you'll wait 200 years for a reply. The misconception is that the galaxy is a connected neighborhood. It's not. It's more like isolated islands separated by vast oceans of space and time. So when we look at distant stars and assume contact is inevitable, we underestimate the tyranny of distance. The universe doesn't forbid company. It just makes meeting it extraordinarily difficult. Let me ask you something simple. What color is a star? Most people say white, or maybe yellow because the sun looks yellow in the sky. But that's another little illusion. Stars come in different colors, and those colors tell us something very precise: their temperature. A blue star is hotter than a white star. A white star is hotter than a yellow star. A yellow star, like our sun, is hotter than an orange one, and red stars are the coolest of the main sequence stars. Now, when I say cool, I don't mean chilly. Even a red dwarf star can have a surface temperature of about 3,000 degrees Celsius. A blue star, over 20,000 degrees Celsius. The color isn't decoration, it's physics. Hotter objects emit more high energy, blue light. Cooler ones emit more red light. It's the same reason heated metal glows red first, then orange, then white as it gets hotter. Here's the misconception. We assume our sun is typical. It's not rare, but it's not the most common type of star either. The majority of stars in our galaxy are red dwarfs, smaller, cooler, and far longer lived than the Sunday. Some may shine for trillions of years. That changes how we think about planets and life. A world orbiting a red dwarf would experience very different conditions from Earth. So when you look at the sky, don't just see white dots. You're seeing a temperature map, a spectrum of stellar personalities, and each color is telling a story about the physics happening deep inside those distant suns. Here's one of the strangest facts about distant stars. When you look at them, you are not seeing them as they are. You're seeing them as they were. Light travels fast, about 300,000 kilometers per second, but space is enormous. Even at that speed, light takes time to cross it. So when you look at Alpha Centauri, you see it as it was over 4 years ago. When you look at a star 1,000 light years away, you see it as it was 1,000 years ago. Now stretch that idea further. When we observe the Andromeda Galaxy, about 2.5 million light years away, we're seeing it as it was 2.5 million years ago. On Earth at that time, early human ancestors were just beginning to use primitive stone tools. Astronomy isn't just about looking far. It's about looking back. Telescopes are time machines. The misconception is that we observe the universe in real time. We don't. The deeper we look into space, the further back in history we travel. Some galaxies we observe are billions of light years away, meaning we see them when the universe was young. And here's the provocative part. Some stars we see tonight may no longer exist. They may have exploded or collapsed long ago. Their light is simply still en route. The sky feels immediate, but it's archival. You're not watching the present. You're reading ancient light. So after all this, distance, brightness, color, stellar lifetimes, what's the real thing we get wrong about distant stars? It's not just a factual mistake. It's a perspective mistake. We look up and see decoration. We see a backdrop, a ceiling sprinkled with lights, something static and quiet. But distant stars are not ornaments. They are gigantic spheres of plasma, fusing hydrogen into helium at millions of degrees. Some are so large they would swallow our entire solar system. Others are so dense that a teaspoon of their material would weigh tons on Earth. We assume they're permanent. They're not. We assume they're small. They're not. We assume they're reachable. They're unimaginably far. And here's the philosophical twist that fascinates me. From one ordinary star, our sun, on a small planet in a spiral arm of an average galaxy, matter organized itself into something that can measure stellar spectra, calculate fusion rates, and determine distances in light years. The misconception isn't just about stars. It's about scale. We underestimate how vast the universe is and how remarkable it is that we can comprehend it at all. The stars don't exist for our inspiration. They simply burn. Yet somehow, in this vastness, atoms assembled into minds capable of understanding nuclear fusion happening millions of kilometers away. And to me, that's the most astonishing thing in the entire sky. Now let's talk about something your brain does automatically. You look at the night sky and see one star shining brilliantly while another barely glows, and you think, that one must be bigger, or closer, or more powerful. Seems reasonable, doesn't it? But brightness is a trickster. There are two main factors that determine how bright a star appears to you: how much energy it actually produces, its luminosity, and how far away it is. And distance is a ruthless dimmer switch. Light spreads out as it travels. Double the distance, and the brightness drops by a factor of 4. Triple it, you're down to 1/9. Think about car headlights at night. A small car close to you can appear blindingly bright. A massive truck with enormous headlights far down the highway can look like a faint spark. The same thing happens with stars. Sirius, the brightest star in our night sky, is about 8.6 light years away. It's bright partly because it's relatively close. Meanwhile, some truly colossal stars, hundreds of thousands of times more luminous than the sun, appear dim simply because they're incredibly far away. The misconception is that your eyes can judge cosmic power. They can't. Astronomers use tools like parallax to measure distance and spectroscopy to determine a star's temperature and intrinsic brightness. We don't guess, we calculate. So the next time you see a faint star, don't assume it's modest. It might be a titan, just very, very far away. And distance, in the universe, is the ultimate illusionist.